I watched my mother die last week, and I mean that literally. I sat at her bedside in a hospice room in New Jersey and watched it unfold, breath by breath. By the time it was over, by the time her chest stopped moving, what I had been witnessing for the better part of 4 days wasn't really her anymore. It was something far older than her, something that predates her, predates me, and predates the entire mammalian lineage by hundreds of millions of years. I was watching her brainstem refuse to quit. And here's what that taught me about resilience, about evolutionary biology, and about what it actually means to be hard to kill. Let's start with the structure. The human brain isn't one thing. It's a layered system built over evolutionary time, each layer added on top of what came before. The cortex, that wrinkled or what's called convoluted outer layer responsible for things like language, planning, identity, everything you'd call you, is the newest, most recent evolutionary addition. Beneath that is the limbic system, or the mammalian emotional brain. And beneath all of it, sitting at the top of the spinal cord, is the brainstem. The brainstem is not sophisticated. It doesn't think, it doesn't ruminate, it doesn't have opinions. What it does with extraordinary, almost irrational stubbornness is keep you alive. Heart rate, blood pressure, breathing rhythms, swallowing reflexes, these are brainstem functions. They run automatically, continuously, without any cortical oversight required. The breathing rhythm itself, that automatic breath that you might have just taken, originates in a small bilateral cluster of neurons in the medulla oblongata called the pre-Bertzinger complex. Smith and colleagues identified and characterized it in 1991. 1991. Demonstrating that this region generates the basic rhythm of respiration in mammals independently of higher brain input. Feldman and Del Negro built on this work, showing the network properties that make this rhythm so robust and self-sustaining. You don't decide to breathe. The pre-Bertzinger complex decides for you, and it keeps deciding long after everything else has gone dark. It's called agonal breathing. It's shallow, slow, jaw-dropping pattern you see in the final hours of life. It's not distress, not a struggle for air in any experiential sense. Pre-Bertzinger complex firing its last autonomous signals into respiratory muscles that can barely respond. It looked like suffering from the outside. I can attest to that. From a neurologic standpoint, it is ancient hardware running its final programs with no operator or cortical presence there. Here's where this becomes a mismatch story. The brainstem is the most evolutionarily conserved structure in the vertebrate nervous system. Fish have brainstems. Amphibians, reptiles do too. The organizational features of the vertebrate brainstem trace back over 500 million years of evolutionary history. Natural selection has been refining and hardening this structure for 500 million years because the organisms whose brainstems kept firing under conditions of blood loss, cold, oxygen deprivation, and traumatic injury survived long enough to reproduce. The ones whose ancient hardware gave up left no descendants. That pressure is written into your neurology right now. The brainstem receives the most redundant blood supply of any brain structure. The vertebral arteries, the basilar artery, the posterior inferior cerebellar arteries forming overlapping collateral networks specifically designed to maintain perfusion even when everything else is compromised. It is the last structure to lose its blood supply as circulation centralizes during the dying process. It was built to be the last thing standing, so it is. Now here's where it gets directly applicable to how we think about resilience in living people. There is documented phenomenon in extreme stress, combat survival situations, catastrophic physical trauma, where higher cortical processing essentially takes a step back. Rumination quiets. The prefrontal cortex, the seat of planning and worry and narrative self-monitoring, reduces its dominant grip on behavior. What remains is faster, more automatic, and driven by older, survival neural mechanisms. Survivors of extreme events describe something like this consistently. A clarity that isn't thinking, an action without deliberation, a strange calm in the middle of catastrophe. The cortex getting out of the way so older, faster systems can operate. From an evolutionary mismatch perspective, this makes perfect sense. The ancestral environment did not reward elaborate cortical deliberation during acute physical stress. It rewarded fast, automatic, brainstem and limbic-driven responses. The cortex is metabolically expensive, temporally slow, and prone to paralytic overanalysis under acute load. Paralysis by analysis. When the situation is life-threatening enough, brainstem suppresses the cortex, and runs on the older hardware. The mismatch is this: we now live in an environment where chronic psychological stress, social threats, status competition, financial anxiety, digital overload activates that same stress architecture continuously, without the physical resolution that ancestral threats provided. The cortex stays engaged and dysregulated when it should be periodically allowed to step back. The brainstem and limbic system stay in a low-grade activation state without the outlet of physical action that would reset them. I understood this in my body during those 4 days. I'd been at her bedside for hours, alternating with my sister or staying with my sister, my family. The hospice room was fine, climate controlled, nice lighting, sealed from the outside. My nervous system was running on adrenaline, cortisol, hypervigilance. At some point I walked outside. I found a trail that led to a gigantic lake. There were trees, uneven ground, water, open sky, and beautiful weather. Within 20 minutes, something shifted that I couldn't have manufactured sitting in that hospice room. This isn't an anecdote dressed as science. Brotman and colleagues at Stanford demonstrated in 2015 that a 90-minute walk in nature or a natural environment compared to an equivalent walk in an urban environment significantly reduced self-reported rumination, decreased neural activity in the subgenual prefrontal cortex, the region consistently associated with negative self-referential thought and risk for depression. Kaplan and Kaplan's foundational attention restoration theory established that natural environments restore directed attentional capacity through a mechanism they called soft fascination. It's engagement that replenishes rather than depletes cognitive resources. Your nervous system evolved in that natural environment. It's calibrated for it. The lake trail wasn't therapy or escape. It was the correct sensory habitat for a stressed mammalian nervous system to regulate itself. I came back from that walk present, functional, capable of sitting with her again. Meanwhile, her brainstem was still firing. The evolutionary lesson here is uncomfortable but honest. Resilience, at its most fundamental level, is not a personality trait. It is not grit in the motivational speaker sense. It is the product of 500 million years of selection pressure on ancient neural hardware that was built, literally built at the genomic level, to keep the organism alive through conditions that should kill it. The brainstem doesn't know when to quit because the brainstem that quit early left no descendants. And when you strip away the cortex, through extreme stress, through the dying process itself, through returning to the natural environment your nervous system was shaped in, what you find underneath is ancient, stubborn, and remarkably hard to stop. That's not inspiration, that's the mechanism. And sometimes sitting in a hospice room into wee hours of the night, early mornings, watching your mother's jaw drop in the silence, mechanism is the most honest and clarifying thing available to you.